I have a separate lecture on LCM. You can have a look at that also. I'll mention the link in the comment section. Here I'll give you another introduction to LCM. So LCM is the lowest common multiple. Lowest common multiple. So the this seems to be tricky, but is a very simple topic. So what it is trying to say is, I'll take a very simple example to explain this. So for example, I have to find the LCM of 3 and 5. 3 and 5. So we'll go one by one. So first thing that is mentioned in LCM is a multiple. So the multiples of 3 are 3, 6, 9, 12, 15 and so on. Basically the table of 3. The multiples of 5 are 5, 10, 15, 20, 25 and so on. So you have written the multiples of 3, you have written the multiples of 5. Now you have to find the common multiple, and it should be the lowest also. So basically we have to find the lowest common multiple. Now if you look at here closely, the lowest common multiple is 15. So the LCM of 3 and 5 would be 15. Let's take another example. Let me find the multiples LCM of say 2. I'm taking very simple example so that you understand the concept. 2 and 10. Now you can write the first multiples of the multiples of 2. So 2, 4, 6, 8, 10 and so on. Multiples of 10, 10, 20, 30, 40, 50. Basically the tables. Multiples is basically finding the table of a particular number. Table of a particular number. So now again we have written the multiples, and now we have to find the lowest common multiple. The lowest common multiple. Basically the first number which is in this sequence, the first number which is common. So if you see 10 and 10, they are common. So the LCM of 2 and 10 is 10. Now there is a word which I want to introduce. I think many of you might not be familiar with this, but it's good to understand this term. The term is coprime. What coprime means is that if you take two numbers, for example 3 and 5, and basically they don't have any common factor except 1. So if you look at 3 and 5, they are coprime numbers because they don't have a common divisor. The only common divisor is 1. But if you look at 2 and 10, there is a common divisor which is 2. So 3 and 5, they are called coprime numbers. Coprime numbers. I won't go into details, but I want to introduce this word into your terminology. There is something called coprime numbers. So you can skip the topic. Coprime is not something very important, but at least you should understand. But 2 and 10, they are not coprime. Now coming back to LCM. For example, we have to find LCM of say 4 and 10. Very simple numbers. So again, you can write the multiples of 4, 4, 8, 12, 16, 20 and so on. And multiples of 10, 10, 20, 30 and so on. Now if you look closely, which is the first common multiple? The first common multiple is 20 here and 20 here. Is there anything else? 4, 8, 12, 16? No. 10, 20, nothing. So the LCM would be 20. Let's find LCM of another group of numbers. For example, say 15 and 10. 15 and 10. So I'll write the multiples of 15. 15, 30, 45 and so on. Multiples of 10, 10, 20, 30. I try to figure out, pause the video, try to figure out. So basically what I'm trying to tell you is, I'm just trying to introduce the concept of LCM as slowly as is possible. Then we'll do a method. Because as you would understand, this is a bit of a tedious method because you have to write the multiples of first few multiples of both the numbers. So this is a bit tedious method. There is a shortcut that will come, and I hope you will have found the LCM. So the LCM 15, 30, 45, 10, 20, 30. So the LCM would be 30. So now we have done 4 examples. 3 and 5 LCM is 15. 2 and 10 LCM is 10. Let me mark it in black. So this is the first set of number that we'll be using this again. We'll be using these set of numbers again. The LCM of 2 and 10 is 2 and 10 is 10. The LCM of 4 and 10 is 20. And the LCM of 15 and 10 is 30. So this is how you introduce the concept of LCM. That basically it's a common multiple, but it's a lowest common multiple. Let me try to go deeper and try to tell you what am I trying to say. There's a lowest common multiple. So let me take example of 4 and 10 again. 4 and 10 again. To let's go a bit deeper. Not much deep, not very deep, but a little bit deep. So 4 to the 8, 4 to the 12, 4 for the 16, 4 5 the 20, 4 6 the 24, 28, 32, 36, 40. So these are the first few multiples of 4 that I have written. Multiples of 10 are 10, 20, 30, 40 and so on. Now look closely, you will understand what I am trying to say. If you want to find the common multiples of 4 and 10. So if you look closely, the first common multiple is 20. Here you have 20. Then you have 40. Then you have 40. So the common multiples are 20, 40, and if you are getting it, basically 60 would be another number, 80 would be another number, and so on. But in LCM, when I'm trying to find the LCM, what I'm trying to find is the lowest common multiple. What I'm trying to find is the lowest common factor. So the lowest common factor would have to be 20. And that is what is the meaning of LCM. That is what is the meaning of LCM. You have to find the lowest common multiple. The lowest common multiple. I hope now it's clear. I'll give you a few practice questions also. Another thing which I want to specify is because I want to make it as beginner friendly as possible. So I'm avoiding 3-digit numbers. If you want to find LCM of 3-digit numbers also, you can find the LCM of 3-digit numbers also. Let me take example of 2, 5 and 10. See, the process remains the same. You can take 2, 5, 10. You can take 2, 5, 10, 15 also. The process will remain the same also. So let me illustrate you with the example of a group of 4 numbers. Process will remain the same. The process won't change. But don't worry about it. So you'll have to write the multiples of 2, 5, 10, 15. You'll have to write the multiples and then you will have to find the lowest common multiple. The process will remain the same. Try to find the LCM. And then let's proceed. We're able to do it. So I've written the multiples of 2. You can check multiples of 5, multiples of 10, multiples of 15. And I hope you were able to find that the LCM is 30. Now, as you will understand, as I have told you before, if you have to find the LCM of 2, 5, 10, 15, and you use this method, it will be a very tedious method. In the exam, you will be doing this only. So I hope you are able to understand the concept of taking LCM. How do you, what's the meaning of lowest common factor? But using this method of writing all the multiples of a number and then finding the lowest common factor is a very tedious job. So what's the shortcut? And now let's try to find the shortcut. Let me take the first question only, the last example that I have taken to start. So what you do is you write the numbers. So for example, I have to find the LCM of 2, 5, 10, 15. So I write the 4 numbers. See, this is not minus, this is just a dash. Dash is basically there to just separate the 4 numbers. But the first thing that you do is you try to take a common multiple. And this method is called LCM by Prime Factorization. So what I am doing now is called finding LCM by prime factorization. So I hope you know the meaning of prime. So prime numbers are numbers like 2, 3, 5, 7, 11, 13, 17, 19. These are the basically these are the only numbers that you will require in let us say 95% of the questions that you will be doing. I'll say 98% of the questions that you will be doing. These are the only numbers that you will be requiring. These are the only prime numbers you will be requiring. It's only at time that they go to 23. I haven't, and that too are very tough questions. So usually when you are trying to find LCM by prime factorization. Usually, no, these are all the numbers that you require. You require 2, 3, 5, 7, 11, 13, 17. So these are the prime numbers that you require. Not even 17. At times, process basically stops at 13. So finding LCM in this process of finding LCM by prime factorization is you list the numbers, you separate them by dashes, and then you draw these lines, a vertical line and a horizontal line. And you try to find the first prime factor which divides two or more of the numbers. So, for example, the first prime number that I can see which divides two or more the numbers is 2 and 10. So, the prime number is 2. So, I'll say 2 ones are 2. Now, I'll write 5 as it is because 2 doesn't divide 5. But 2 5s are 10. And I write 15 as it is. I hope this is clear. So, I divide 2 by 2. 2 ones are 2. 5 is not divisible by 2. 10 is divisible by 2. So 2 5s are 10. And 15 is not divisible by 2. Now I look at the next lot of numbers. And I try to find a common factor which divides 2 or more numbers. As you can understand, that number is 5. So 5 ones are 1 is as it is, 5 ones are 5, 5 ones are 5, 5 3 are 15. And then I just have single number, so I'll write 3. So this is as it is and 3 ones are 3. Now what I suggest to students is that if they do this method properly, write the numbers one below the other in a symmetrical fashion. Write it like this. Don't write zigzag. Otherwise you'll make a mess of the process that you are following. Now what will be the LCM? The LCM would be 2 multiplied by 5 multiplied by 3. So 5 3 is 15, 15 2 is 30, the LCM is 30. Here also if you see, the LCM was 20. So this is a shorter method rather than writing all the common divisors. I'll be using these same numbers when I'm doing the addition of fractions also. So don't worry, this will be very useful for me. So please try to do with me all the questions. Because we'll be using the same set of numbers to find the addition of fractions. Now let's apply prime factorization to the other numbers also. So I'll apply prime factorization for 15 and 10. So 15 and 10, I separate them by a dash. Then I draw a horizontal line and a vertical line. Was it the first prime number which divides the two numbers? The first prime number. 2 is not there, 3 is not there, 5 is there. So 5 3s are 15, 5 2s are 10. Now I will rub this to make some space. Now, is there a common factor of 3 and 2? No, there is no common factor of 3 and 2. So, what I can do is, I can write LCM. So, once you have reached a stage where there is no common prime factor, then you can just multiply the 3 numbers which are remaining. So, LCM is 5 into 3 into. So, 3 to the 16, 3 to the 6, 6 5 are 30. So, the LCM is 30. As before, the LCM is 30. Before also, we found the same LCM 30. Please try to do whatever I am doing on the screen on your own, because that will help you when we are doing the fractional addition also. It will help you a lot. Now let's find the LCM of 4 and 10. So again, I'll have to draw. Let me draw here. So 4 and 10. The first common prime number which divides both the numbers, that is 2. 2 2s are 4, 2 5s are 10. Now, is there a common factor of 2 and 5? No, there is no common factor of 2 and 5. So, what will be the LCM? The LCM is just multiply these three numbers. So, 2 into 2 into 5. So 2 2s are 4, 4 5s are 20, the LCM is 20. This LCM is the same as we had done. Now let's find the LCM of 2 and 10. Let me make some space so that there is no confusion. LCM of 2 and 10. Write the numbers. Write the numbers. Find the first prime number that divides both these. The first prime number is 2. 2 1s are 2, 5s are 10. And now the process stops because 1 and 5 are there. So the LCM would be multiplied by 5. It will be 10. So here 10. LCM would remain the same, any method that you find. Now 3 and 5. See, 3 and 5 have are basically co-prime numbers. So whenever you meet any co-prime numbers, you can just multiply the numbers. In the practice set that I will be giving, I will be mentioning a few set of co-prime numbers also, so that you can have a look at the PDF also. So otherwise, if we follow the tabular method, so 3 and 5, there is no common divisor, no prime factor divides, no common prime factor of 3 and 5. So I just have to multiply, so my answer would be 3. So we have found the LCM of 3 and 5, 2 and 10, 4 and 10, 15 and 10. Then we took a 4 digit and found the LCM. I'll mention few practice questions in the PDF also. You can practice that also. See, LCM, finding LCM is a critical part of addition or subtraction of fractions. Let me take few more examples so that things are clear. Let me take example of say let me take example of 21 and 45. 21 and 45. Try to do on your own. Pause the video, try to do on your own, and if you are not able to find, then please look at the solution. So 2 and 45, I have separated them by a dash. Then I draw the vertical and horizontal lines. The first prime factor which divides both them. So the prime factors that I have are 2, 3, 5, 7, 11, 13. So you have to start with the lowest. 2 doesn't divide 21 and 45. 3 does. Now, is there a common factor of 7 and 15? No, there is none. So the LCM would be 3 into 7 into 2. So you find the number and that is the answer. So 7 3 is 21, 15 1s are 15, 15 2s are 30, 3 1 5, 3 7 5 are 25, 3 1 5 is the answer. So I'll give you a set of few numbers for whose LCM you can find. Please try to practice that. If you are completely a new beginner. And then there is another thing that you need to understand is there is something called divisibility roots. Divisibility roots. Divisibility roots. I'll also attach. I have a lecture on divisibility roots. Please find that in the comment section because when you are trying to find the common factor, you'll have to look at the divisibility rules also. So you can refer to that lecture also. So till now we have understood what are LCM, and now using this concept of LCM, we'll start doing fractional addition and subtraction. So let's start.